Welcome back to another tutorial of codeindia. This is SpriteKit tutorial. In this part of the tutorial, we are going to learn SKEmitter Node. We will be learning the SKEmitter Node, all about the SKEmitter Node, and we will be creating this twinkling star project. See, I have already added the sorts for this. So, we are going to create this twinkling star along with this moon, which is in orange in color. We will also create this moon, but we will create this moon using the SKShape node. So we will also learn SKShape node a little bit in this part of the tutorial. So what is SKEmitter Node? SKEmitter Node is a built-in particle editor that help you to create effect like fire, snow, rain, smoke almost entirely through a graphical editor to create a special effect with SpriteKit. So when you must have seen in some project there is a very good UI for a fire, snow, rain. These things have been added in a special editor. Bunch of editor has been given for this particle emitter, named with a particle emitter, and you can add this editor using using the code, or you can use a graphical user interface for graphical editor also for this. So this is what the SKEmitter Node is. This creates a effect like fire, snow, rain, smoke. These are the things that are already built in SpriteKit. So you can add these things. Snow, rain, smoke, they are already built in. Fire. So you can use that in your SpriteKit project. So this is the SKEmitter Node. An SK node that produces a colored or textured particle. This can also be said to be a SK node that produces a colored and a textured particle. Emitted particles are not directly accessible to the application developer. Their behavior can be controlled either by a creation parameter configuration in SKEmitter Node or SK keyframe sequence. This is very important. SK keyframe sequence is also used to add all the parameter to this emitter node. So these things are all the parameter, all the functions are not accessible to the developer, but they can be used using the creation parameter configuration that is given in SKEmitter Node or by using SK keyframe sequence. We will be using SK keyframe sequence for creating these twinkling star. SKEmitter Node object is a node that automatically create and render small particle sprites. Particles are privately owned by SKEmitterKit. Your game cannot access the generated sprites. Emitter nodes are often used to create smoke, fire, spark, and other particle effect. A particle is similar to SK sprite node object. It renders a textured or untextured images that is sized, colored, and blended into the screen. However, a particle differs from the sprites in two important ways. The first one is a particle texture is always stressed uniformly, and second one is a particle are not represented by object in SpriteKit. This means you cannot perform node related task on particle, nor can you associate a physics body with the particle to make them interact with other content. Although there is no visible class representing the particle added by emitter node, you can think of a particle as having properties like any other object. So this is what the SKEmitter Node is. SKEmitter Node is similar to SKSprite node, but there are some limitation here because SK particle emitter node here, in case all the texture are uniformly stressed and you cannot access the parameters or the character of these, and you cannot associate a physics body to these. So this is what the SKEmitter Node is. There are various properties of SKEmitter Node: emission angle range, particle alpha speed, particle birth rate, particle color, particle lifetime, particle speed, particle color blend, particle position range, particle speed range, particle action, and SK keyframe sequence. So we will be discussing these one by one. What is a emission angle? Emission angle is the average angle in radian at which the particles are emitted. Emission angle range is a range about the emission angle from which a particle are emitted. Particle alpha speed is the amount that the particle alpha will change per second. Particle birth rate, amount by which a particle are created. Particle color, the color of new particle. Particle lifetime, the average particle lifetime. Particle speed is the average speed of a new particle. Particle color blend, we are going to use all these properties in this project. So particle color blend. Blend is average initial blend factor for new particles. See, the default value of the color blend is 0, which means that the texture that is used here, the texture used, the color is here is used as the texture of the color of the texture, ignoring the particle color. Otherwise the texture is blend with the color. The maximum value is 1, which means the particle render with the full tint color. So we will be using this. Particle position range will be the range about the average position of new particle. Particle speed range is the range about the average speed of the particle. Particle action is the immutable action that a new particle will execute. SK keyframe sequence. SK keyframe sequence is an object that can control the properties of the particle emitted by SKEmitter node. This is very important because we will be creating the twinkling star using this SK keyframe sequence. So let us move to Xcode for creating this project. So let us open our Xcode and create a new Xcode project. Select game, click next, name of the project. The language will be Swift, game technology will be SpriteKit, click next. Put your project in a folder. I am putting this inside this folder. Now my project is created. I will be presenting this game scene from my game view controller. I am not going to explain this because I have already done this. If you haven't gone through my previous tutorial and you are a beginner, just check the beginner tutorials and then come back to this one. I have already created the beginners tutorials. Let me just remove the unwanted code and present this. I will provide the background color to game scene, black color. As you can see, I have a black background. Now my game scene will be presented. I have created the SK view object and I have created the game scene object. I have presented the game scene inside my SK view. Now my game scene is presented. Now what did move function will be called inside game scene. Now here, before creating this twinkling star project, Let me show you how we create the basic SKEmitter node. We create a basic emitter node by using .sks file or by adding .sks file from here resource. See, you have resources. Inside this iOS you have a resource folder. Inside this resource folder you have a SpriteKit particle file. I will select the SpriteKit particle file, and here you can see we have several options to add. Broken, fire, fireflies. Let me use this fireflies. Click the next button. Name this. Let me name this file as fly, and I will create this. My .sks file has been created. See, this is fireflies. Now, how to add this call this SKS file inside my game scene? I will create a object of SKEmitter node. If let emitter node is equal to SKEmitter node, and I will provide this file name to SKEmitter node. File name is flies, and I will position this emitter node. Emitter node dot position. Let me position it to the mid of the screen. So I will write CG point. Mid of the screen will be frame dot midx and frame dot midy. I will add child, self dot add child, this emitter node. Now my emitter node will be added. See, if I run the code now, you can see the firefly will be added. Now if it's white, color ramp, blend, these things, see the this one has been added. You can see the bottommost space, top and the bottom space, gap, margin, top and the bottom margin in this simulator. You can remove this top and bottom margin. I have already added a tutorial for that. You can do that using that. You can remove this using that tutorial. So I'm not going to explain this. You can, if you want to remove this, you can use that, go through that tutorial and it will be removed. So let us now add our let us add the twinkling star. So let me select the iPad so that whenever I run the code, iPad screen will open. Now I will remove this code because this was only for explaining you how to add a SKEmitter node. We will create this star project. For that, you can see in this star project what basically we have done is we have created 3 layers of SKEmitter node. The first layer, the size of the star is big. In the second layer it is a little bit smaller. In the third one it is very small. So this is how we are going to create. We will create 3 layers for SKEmitter node. So let me create 3 basic functions. The first function will create a star layer. And how we will create this star layer? This star layer I will create using another function which give me SKEmitter node. this function add SK or you can say add emitter node, and this emitter node will, here we will take several parameters so that we can vary those parameters. Now let me create a let emitter is equal to SKEmitter node, and what we are going to do, we will be returning this emitter node this from this function. Now we will use the variable emitter is equal to add SKEmitter node here like this. Also we will be taking several parameters. The parameter that vary will be speed will be CG float, then it will be the lifetime will be also CG float, then scale, the size will vary, no, so we will take scale is to CG float, the birth rate, it will also be CG float, the color, it will be SK color, and the scene, if you want to take, if you are creating this a singleton, you can use a scene, but I am not creating a singleton, so I am not taking a scene. So this I have created this function, so I will call this function add SKEmitter node over here like this, and I will create this variable. First of all, I will take the speed minus 48, lifetime I will take self dot frame dot height divided by 23, scale I will take 0.2, and birth rate I will take 1, color I will take SK color dot dark gray. This is my first layer, or you can say layer, emitter layer, you can say, name it emitter layer. Now I will do one thing, I will add child this emitter layer. This is the first layer. Now I will create another layer with this create emitter node function. Since this is variable, I can vary the value. Now I will change this minus 48 to minus 30. Lifetime I will change to minus 10 divided by 10. Scale I will change to 0.5, and birth rate I will use 2, and the color I will use the gray color, and again I will add this layer. This is the second layer created. Now similarly we will create the third layer varying the speed and all that. I will take 20, I will take 5 or 15, you can say. Let me take 5 divided by 5. Scale I will take 0.1. Birth rate I will take 5. And this color I will take system gray like this, and I will add this layer also. Now my 3 layers have been created. Inside this add emitter node, we are going to use these parameters, and we are going to create the star image. See, here we have a star. No, I haven't used any image for this star. What I have used is a text. So we will create a label, SK sprite label, and we will add this text, star text, and we will create a texture view, and for that texture view we use a texture from that star label. So texture from star label. we will be taking. So, and we will use this texture view to be added to our SKEmitter Node particle view. So this is how we are going to create this add emitter node. Again, we will add the twinkling effect to these stars. Twinkling effect to these stars. See, the color of the star are varying very differently. Yellow and white. So this is the twinkling effect. This color has been changing continuously. So we will use SK key factor for that. SK keyframe sequence. And for that we will create another function saying that add twinkling effect to star effect, and we will call this add twinkling effect inside our add emitter. For every emitter node we will add this twinkling effect, and we will write the code for adding this twinkling effect to our emitter node. So this is how we will proceed. We have already created the layer. We will be creating the emitter node and then we will creating the twinkling effect. So this will take the emitter node and this emitter node will be passed here. Now let us inside this add emitter node, what we are going to create? We are going to create a label, and the text of the label will be the star image. You can see the star has been added, so the label text of that will be that star image, and we will create a texture view, SKEsprite view, and the SKEsprite view will take a texture from that star label. So this is what we are going to do. We are going to create a SKElabel node. The font name I have taken Helvetica, font size I have taken 80, and I have used this star text. This kind of a star text you can search online. There are several other text available there. I have used this one. So this is the star text. Now I have created a star label, and now I have taken a texture view, SK view, texture view, and the texture view dot texture, the texture I am going to create from this texture view, and this texture view dot texture from star. Texture will be texture view that dot texture from star, and now my text also, the texture dot filtering mode will be nearest. What is the meaning of this filtering mode to be nearest? This means that the points will be the nearest. It will be a nearest, or you can use this another. There is a text filtering mode is nearest and far. There are two kind of a filtering mode. If you use this jump to definition, you can see the filtering mode will be, see, the available filter nearest and linear. The nearest will give you a blur kind of a image, and a linear will give you a exact somewhere different kind of a. This is a texture mode is, we are taking this nearest. So this will give you a blur kind of image, a star kind of effect. Whenever we are using this texture from a texture font, we use this filtering mode. So this is how the texture view has been used. Now we have already created a SKEmitter node. Now what we are going to do, we are going to put all the parameter to emitter node dot particle texture, particle texture is there. So this particle texture will be this texture which we have taken from a texture view. Now emitter node dot, we have a speed, so we will use particle speed, and particle speed will be speed. Now texture mode dot particle lifetime, will be this lifetime. Again particle emitter will be dot particle scale, and this will be the scale value. You can learn about these parameter, more detail about this parameter from the Apple documentation or by experimenting these things by your own. Particle birth rate will be this birth rate. Again particle color will be this color, and now it is all done. Now we will add the twinkling effect and the return this emitter. So this is done. Also what we are going to do, emitter dot particle range, particle advance particle color blend will factor. We will use color blend factor will be 1. We need the tint color, we don't need the color of image. Particle dot advance emitter dot particle we will use color blend mode. Particle blend mode will be 1. See if you use this M2 definition. Okay, factor will be 1. Particle we need a color blend factor over here, and we need a particle C emitter dot position, thereafter we will add emitter dot position, particle position range, and we will use emitter dot advance simulation time. These 3 things will be added to complete this position, particle position range, particle speed range. See, the position we will take a mid of the screen. The particle position range we will take a CG vector, and particle position range means the range in which the particle will be emitted. This will be the maximum of the x, and delta y will be 0. Advanced simulation time. What is the advanced simulation time? Also the particle speed range we need. Particle speed range we will take 16. You can take something else also. Advanced simulation time will be the lifetime. What is the advanced simulation time? Advanced simulation time is the, see, time interval. It will be time interval, and it will be time interval will be lifetime. So what is the advanced simulation time? This is the simulation of the time for which the particle will be emitted, particle will be simulated. So it will be the lifetime. So these things have been added. Now we will use this twinkling effect, and this is all done. Let us see if we do not add anything in the twinkling effect, what happens. I have changed this scale to from 0.5 to 0.15 because the middle layer will be a very bigger if I use 0.5 value. So let me run my code and check. See it is okay, but what is missing? The twinkling of the star effect. The color of the star is not changing randomly from yellow to white. So for that we will use the SK keyframe sequence and we will create a method, twinkling star method. See, create this, add a twinkling effect. We will use let twinkle. We are using 20 stars. 20. Let twinkle per rate or twinkle, if number of twinkle or twinkle rate, we can say twinkle rate is equal to 1 divided by CG float, this twinkles, or you can say twinkle time will be 1 divided by this twinkles. Now what we need to do is we need to add a color sequence. A color sequence will be a variable color sequence is equal to SK key frame sequence, and this will have a capacity of this twinkle multiplied by 2. Twinkles multiplied by 2. Now we will create a for loop, and this for loop will run from 0 to 3 dot and less than value, less than this twinkles. And here we will add the keyframe to this color sequence. The color keyframe will be CG color, SK color dot white, and the time will be this. The time will be this one. Time will be, see, time will be this. CG float, time will be CG float I multiplied by 2 multiplied by twinkle time divided by 2. Also again add keyframe, and the second color will be yellow. So we will add a keyframe value to be yellow. This is a twinkle time divided by 2. Now what we are going to do after this for loop, we will use this emitter dot particle color sequence is equal to this color sequence. Now this is going to add this color sequence to our stars. Let me run my code. Now the twinkling effect will be added to this star. See, the color of the star has changed from grey to yellow and white, and it is looking nice. Let me add the moon. Adding a moon is very simple. We are going to use the SKEmitter Node. You can say add a moon, and moon will be let moon node is equal to SKEmitter Node, and this will be a circle of radius. We will take 50 or 100. Let us take 100. Again moon node dot stroke color will be UI color dot black or blue or anything you take. Fill color will be orange. fill color will be orange or yellow as you wish. SK color dot orange I am taking, and moon node dot position will be, I am taking mid of the screen, CG point, and this will be the mid of the screen, frame dot mid x and frame dot mid y, frame dot mid y, and then Z position will be 3 you can say, and add child moon node. So we will add this moon in our, after adding this star we will add this moon. Let me run my code. See, the moon has been added and it is looking nice. You can send this moon a little bit backward using this Z position to be -1 or something like this. Let me use -1 and see if moon is sent back. Now this is all done. So with this we come to end of our tutorial. See you in the next tutorial. Don't forget to like and subscribe my channel. Also write if you want to learn something else, write me in a comment section.